Hello everyone. In this recording, I and my team members will analyze baseball to see what features impacts a team's chances of winning. I'll start off by providing an overview of baseball, and then we'll look at what features we selected that we believe impact a team's likelihood to win, and then we'll go into details about the models we created, and we'll talk more about how they helped us narrow down our selection. Then we'll validate those models, and then we'll use them to make predictions to see if teams are more likely to be successful in 2 years. Baseball is one of those popular sports that have evolved from what it used to be to what we have today in terms of team performances. There are public records that show increased team performance over time, and this is due to changes in strategies, rules, and techniques that have been incorporated into the game. And so, based off this public record, I and my team members are analyzing a data set that spans before 1920 to 2010 to see if teams are more successful with high offenses, tight defenses, or a balance of the two.
Feature selection. Select the best features from many available features with only one goal: to improve the prediction accuracy. Presenting on the feature selection today, we will begin with the offensive features, where we have hits, at-bats, runs scored, and walks ranging from 0.73 to 0.66, each suggesting a strong positive correlation with games won. Next, we have the defensive features, with the infield putouts and fielding percentage suggesting a strong positive correlation, where shutout and strikeouts allowed are suggesting a more moderate positive correlation. When taking into consideration all features, the top features that have a high correlation with our target variable are displayed under the third heat map here, combining all features. This would suggest that these are the best features that would bring us towards our goal of improving the prediction accuracy, as we can interpret here that when the target variable increases, the selected variables tend to increase as well.
So now we're going to look at the linear regression model of each of the selected features that Asia covered over the 4 different periods. Starting with the dead ball era, where during this time there was no scoring games and no home runs. Here is a summary table view of the linear regression model that we pulled using stats model. In the Jupyter code below, we import stats model formula API as SMF, and then using the first line of code to create a fitted model using the different variables with offensive, defensive, and combined features. We then use the lm1.summary line of code to view a summary view of the fitted model so that we can interpret and compare each model. Let's focus our attention on the R-squared of each table, as it's the primary metric for evaluating the strength of a given model. It tells us how well does the model fit the data and the portion of variance explained, meaning the variance in the observed data can be explained by the model. Offensive has an R-squared of 67%. Defensive has an R-squared of 68%, while the combined variable has an R-squared of 96%. We can say that this model is a better fit to the data than the other two. Looking at the p-value, we can also see that they are less than 0.05, so the features are statistically significant. These features include net runs, at-bats, infield putouts, and hits. These are all positively associated with games won, with the exception of at-bats. Moving on to the live ball and integration era, this era is characterized as increase in offenses, which include home runs, batting averages, and runs scored. We use the same code to pull the summary view of the linear regression model for the period between 1920 to 1960. When we compare the R-squared values, we can see offensive has an R-squared of 47%, defensive has an R-squared of 34%, and combined has an R-squared of 92%. We can say that the combined model is a better fit than the other two models at explaining the variance in the data. P-value also are less than 0.05, and that there is an association with games won with combined offensive and defensive features. All features are positively associated with games won, with the exception of at-bats in this model. The next era is expansion and free agent era, where it was characterized with increased home runs, team size, type of players, and locations. Again, when we look at the R-squared values as the primary metric to evaluate the strength of the model, the combined variable is significantly higher than the other two models at 92%. P-value continues to be less than 0.05. The combined variables continue to. The steroid and post-steroid era saw an increase in offenses owing to the alleged use of PEDs. Looking at the last period, we continue to see a trend where the combined variables model has a significantly higher p-value than the rest of the models when offensive and defensive are independent. The combined variable model has an R-square of 90% while p-values are less than 0.05. We are seeing a trend that when a team has both offensive and defensive features, they are likely to win more games, and we should use this as a basis moving forward when we consider how to build a franchise.
Myself Prayas and I will present model validation. How we will evaluate our model. First, we need to split our data into training and testing. 70% data we will be utilized for the training our model and 30% will occupied for testing. In order to split our entire dataset, we will use skitlearn library and using the train test split functions for splitting the dataset. In order to train our data, we will use linear regression method, which is quite popular tool. Why we are going with this ordinary least square, which is also called linear regression method, because it's a commonly used for predictive analysis, and our main aim is also similar to predict how many games won by particular team using the given variables. In order to check our model with the statistics, we are decided mainly two criteria: RMSE value and R square method. RMSE particularly used for testing the data, and R square in order to check how our model will perform. Mm, as Isa already explained about what kind of variables we are going with for the offensive one and for the defensive ones. Here we will see that how the data is distributed for the that all independent variables. For the run score and the walks, we clearly see that the data is normally distributed. However, in field putouts, field percentage, hits, and at bats showing a negative trends. On the other side, shutout showing positive trends. uh, how our training model performed, which we will see that using the R square value, which is showing 0.918, it means that that model has 91.8% accuracy. And also similar for the RMSE value, that is very low, and which is so that this model is very accurate and validate. We will see that the same trend with all the periods. And also we also notice the one thing that RMSC value has been decreased with the period, so it means that our predictions are relatively accurate with the periods. Now it's time to check our model with real numbers. So in the actual game ones and predicted game ones through our models are pretty similar. There is a very slightly difference between both of them. So we will see that in 2007 it's showing 85 game won, and our model is also predicted 85. In the 2008 it's showing 82. However, we predict that 81 game the win by particular teams. So there is only one difference between predicted game ones and actual game ones. So it means that our model is valid and perfectly fit for the predictions. Now we will check the coding part. This is the code for splitting our data into training and testing. For the linear regression, this is the code for to train our data. In order to test the data, this is the code, and we will see that there is a very slight difference between the predictions of prediction game one and the actual game one. So our model is validated. We will see that through that coding.
Thank you, Priyash. Hello everyone, my name is Kai, and I will walk you through the prediction analysis using our model. As we learned, the main purpose of the model building is to generate good predictions for unseen future. Here we are going to predict the win score of New York Yankees and Toronto Blue Jays of year 2012 and 2015. This slide is the multilinear regression model that we are using. From previous sections, we see that the combination of defensive and offensive variables produce better model. Therefore, we chose 4 variables from both sides. Y is a game won, which is what we are predicting. X1 to X4 are the dependent variables that we use to predict. Beta 0 is the intercept value, and beta 1 to beta 4 are the coefficient values. Epsilon is the residual. The data to build and train the OSL model is from 1990 to 2010. Here it is showing the OSL regression results. R2 score is 0.958, and p-value of these 4 variables are all below 0.05, which indicates that the model is very accurate. The red box values are the ones used in the regression model. Here is showing the Python code and results, and the top part is the stats model library for the predictions. The bottom part is the results, showing actual values versus predicted values. This bar chart shows visually the predicted value versus actual value, as well as the residual value. There are quite a few metrics to measure the forecast accuracy, and we are using 2 of them here. This slide is showing the R2 score, which is 0.75, which means that 75% of the variance of dependent variables can be explained by the variance of the independent variables. Usually, the R2 score of 0.7 is considered good. The other way to measure forecast accuracy is using MAPE, M-A-P-E. In our model prediction, it's 3.13%. A MAPE less than 5% is considered as an indication that the forecast is acceptably accurate. Just a summary of the prediction part. We use the multilinear regression model to predict the Yankees and Blue Jays in year 2012 and 2015. The predicted win numbers are really close to the actuals. Now I'm going to spend a few minutes on the Python code. Python code for the predictions. First part is the dataset we built for these 2 teams for those 2 years. And we use the model from previous section, just predict the games won for those 2 teams. And this is the results. After that, we just calculate R2 score using scikit-learn, the package, and calculate the MAPE value, use scikit-learn as well. This is the bar chart we just showed. And after all this done, we just run the whole thing. Thank you very much. Now I'm handing it over to Florence.
Based off our analysis, there needs to be a balance of both offensive and defensive features for teams to win games.